Okay, let's see, get the attendance done. Michelle? Yeah. Abir? Yeah. Autumn? Celine? Sophia? Mubarak? Jadera? Mohammed? Sabrina? Sabrina? Oh, she's gone, isn't she? Yeah. Moza? Angela? Ahmed? Safra? Neil? Mahmoud? Gafar? Amjad? Yes. Zara?
Here.
Mo? Daniel? Daniel? What? He's sick, okay. Savi? Sabrina? Alfreda? Arya? Judy? Yungpang? Amna? Mariam? Excuse me, I'm a professional. I know what I'm doing. Right. Let's have a look. So, in a moment, we'll have a look at some exam questions if we like. Is there any particular topic we want to be looking at? Yeah. Which one?
Partial fraction.
I do the partial fraction when we finish that chapter. It might be a bit early yet, so. Yeah, maybe some integration questions would be good to do. We already had a full day or two on that, didn't we? I think integration would be good to do. Yeah. Anyways, that'll be in a moment because we'll have a look at that integration question you had earlier. Integrate tan inverse x over 1 plus x, 1 plus 1 over x squared. dx. Guys, can we look up, please? Thank you. Let's have a look at this one here. So I think the first thing we want to do, LIA, is split it like this, tan inverse x times 1 over 1 plus 1 over x squared dx. Yep. Also, I think it would be a little bit nicer if we multiply the top and bottom here by x squared, just to make it one fraction instead of two fractions. So we'll get x squared over 1 plus x squared, or x squared plus 1, same thing. Wouldn't we? Yeah, we would. Yeah. Is that okay? Yes, checks out? Yep. Okay, and this looks like by parts. So we have here f derivative, g derivative I mean, and then here we need integration to get the g. So that's a side problem. So I'll just give you a minute to write that much down and then we'll have a look at the side problem. We got that? We got that? Okay.
Now you have to integrate separate, yeah?
On the side, yeah. Yeah.
Wouldn't be this complex?
Are you using up one of your three?
Yes.
It would. Well, I don't think it would be because this is already, I can see, going to be a little bit tricky. Okay. Yes?
One point. When you multiply by x squared, where did the 1 over x squared?
What's 1 over x squared times 1? Times x squared? No. 1 over x squared times x squared?
1.
Yeah? Guys, no, come on, come on, come on, come on. No, I'm not continuing with people talking, please. All right. Now, we have to go to the side problem here. We have to integrate that fraction. So on the side here, we're looking at trying to integrate x squared over 1 plus x squared dx. Now, we could try substitution. I don't think that would be too helpful. Well, the only choice we have for a substitution here is 1 plus x squared. That would become, that might be helpful. So don't write this part down just yet. Let's just see if the substitution would help. I somehow think it would not help, but let's just see. U equals x squared plus 1. So du dx equals 2x. Okay, so that means dx equals du over 2x. Let's see what happens. This is integrate x squared du over 2x, and here this is a u.
1x goes.
That goes, doesn't it? And that's a half integrate x over u du. Now we have a problem. We still have an x and a u. So it doesn't look like the substitution would work. Okay. What's our other choices? Well, by parts is one choice. And also we could try to split this up as well. And it looks like substitution definitely doesn't work here. So let's try by parts. So we could split this. This is a little bit like what we had earlier. This times this, isn't it?
Yeah.
Yeah, so let's see what we get here. F derivative. Isn't that right? Yeah.
And this is done.
How do you know which one to put first?
Usually for these fraction ones, you want to make the first one the non-fraction and the second one the fraction. And this comes up in the exam sometimes. And I don't think they tell you this always in the exam. So look, this particular problem I'm doing on the board right now, that could be an exam question. And there's no guarantee that they'll tell you which is the f and which is the g derivative. So you might want to make a note somewhere that, as Mo was asking me, it's usually the non-fraction is the f and the fraction is the g derivative, usually. Okay, so this one is nice because here we want to integrate 1 over 1 plus x squared, and we know what that is. That's a special one. That's tan inverse x. So this becomes fg minus integrate f derivative over, sorry, what is it? F derivative g, isn't it? 2x tan inverse x dx, like that. Yes? So now we have to calculate this. Fg, no, hang on. Let me check. Fg minus f derivative g. No, that's right, isn't it? Yeah, that's right. Okay, so now we go to the side. I think I'll just take that 2 out in front. So now I'll go to the side. And I don't think this one will be too bad, because I think this will be another by parts, isn't it? Is it the right way around? L-I, no. L-I-A-T-E. All right, so F is
Tan.
x.
Oh.
No, it's not. Sorry, you were right, yeah. F is tan inverse, and its derivative is 1 over 1 plus x squared. G derivative is x, and here
Is x2
X squared.
yeah, a half x squared over 2. So this will equal fg minus integrate f derivative times g, which is a half x squared there.
What? Yeah.
Yeah? I just put the half out. Now you might think, oh, I have to continue now, but no, because what I've done is I've managed to get something which I've seen before. So we need to start looping back now. So what I'll do is, remember this was the integration of tan inverse x. So that can sub into there. So if we go back up, this now is x squared tan inverse x minus 2 bracket now it's nice that the half is there because you can see what will happen. Minus a half integrate x squared over 1 plus x squared dx. I can cancel that with that with that. And let me just open the brackets. X squared tan inverse x minus x squared tan inverse x. Well, that's really nice because they cancel. Minus minus
Plus.
plus. So that's integrate x squared over 1 plus x squared dx.
Is this a never-ending loop?
Well, let's see. Let's go back a level. Why were we doing this? Because at the very beginning we need to integrate x squared over 1 plus x squared. Haha, that's
This is a
funny.
never-ending loop.
That is hilarious. Did you know that was going to happen? Is that what you asked it? So, that's a problem.
Why did you put it back into integration form?
No, because what happened is when I got to this step, I had something which I had earlier.
What if you try to solve
It's a never-ending loop.
by square?
It's a never-ending loop. No, it's worse than a never-ending loop. What I've done is I've managed to simplify this into this, which of course is it's useless. Yeah, it's useless.
How
All right,
about-
that's disappointing.
How about you try and you might not like
No talking. I'm thinking. I'm thinking. How can we integrate this? No.
Make u equal to x squared.
Make u equal to x squared.
That will work.
you eliminate nothing. Yeah, you eliminate nothing. You do absolutely nothing. Can I propose something?
No. The only way I can do it, Amjad, is using complex numbers, which only half the class have seen.
Can I propose
It's
something?
really advanced. Advanced.
And also, I need to do improper partial fractions. Do you really want to see it?
Maybe you can give him your paper later.
So the way I need to continue with this is not until we've covered the last lesson in the workbook.
Then proper.
Yeah, because remember I said last time, proper is when the top is smaller than the bottom. Whereas this one here, the top, is the same as the bottom. And we call that one improper, which is the last lesson. So it's not until the last lesson that I think we can do this one. So you will have to ask me again after we do the last lesson. Okay?
Can I propose something?
Go on. Now this better be good.
You might not like this, but why not take the 1 over
Yeah?
1 over 1 plus x squared as the f instead of g?
Swap it around?
Yeah.
It's possible.
See, you could have this. But you always assume you have a bad idea.
That's because your track record has been so far not perfect. You'd think, now it's possible, okay, let's try switching it around. So we have 1 over 1 plus x squared dx. That could work. Let's see what happens. So f is that. Now we need the derivative here, which is the quotient rule, right? Which is the bottom squared, the bottom times root of the top minus the top times root of the bottom. And then here, x squared, and then this is x cubed over 3. I'm not seeing this becoming easier. Because this is equal to f g minus integrate f derivative, which is 2x over 1 plus x squared, squared x squared
This is worse.
dx. Yeah. 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 So, I'll... This doesn't add to your success rate. Okay. let's have a look at some past papers now, and we'll have a look at some integration questions. So we'll open up last year's exam.
I figured it out.
Sorry, you've used up your chance now.
It's actually really easy.
Of course it is. Right.
After seeing the answer, I remember taking this one.
It doesn't count if you've seen the answer.
Yeah. You add a 1 and a -1 to the numerator. And you can
Make 1 plus x squared.
and 1 over 1.
Yeah, then you'll have a u squared.
Then you get an x and a minus 10.
Well, that's a nice one then, if it is just that.
Yeah.
But that doesn't count as a success for you. That just
I know.
counts that you can read something.
Yeah.
Which we discussed earlier in class, didn't we? Group B students. No, who did I have last? Group A students. Maths for science, okay. 18, 19, is it? What do we have? 17, 18? 17, 18. Let's look at version 1. Okay, so what's the first integration question in section A? Yeah, yeah. Can we see? No? Yes?
No,
It's just a desktop, is it?
Yeah.
it's your laptop.
My laptop, oh, even. Can we see? Yeah, okay, let's see. So the first integration question is here. I thought we did this one. Ah, but we didn't do this one.
No, we didn't.
Yeah.
We didn't do this by parts one, did we?
We did.
We did?
Yeah.
What? No.
I remember it. You know it.
Yes.
Or maybe not.
Here is a partial fractions question that you should be able to do. I just want the A and the B here. What would be the best method here?
Method 2.
No.
1.
No.
Three.
Three.
Just one.
But it's
Multiplying.
not.
No, the cover up method where you delete and sub in the value of x. This is pretty good for 3 marks.
Which question is this?
Oh, this is B3, B part 1.
Do they always give us the factor?
No. No.
But isn't linear too complicated to use method 3? And that,
No.
yes, that is one of my questions.
No. Method 3 is best when it is exactly like this. You haven't finished already? Yes, yeah, yeah. Okay, should be nearly finished it by now.
Yeah. No.
Yeah?
Yeah.
Okay, let's have a look. Can we switch to the the notepad?
Yes.
Yeah. Right, so let's see. I have 3x plus 1 over x minus 1 times x plus 2 equals a over x minus 1 plus b over x plus 2. So method 3 works nicely here. If I want to get this number, I have to delete the x minus 1 and sub in what value of x? 1. So that would be 3 times 2 is 6. 6 over 3 is 2. And now here I covered that up and sub in minus 2. So that's minus 1. It's minus 1, is it?
Yeah, no, it's 1.
That's 1.
In total.
Yeah.
That's really good for 3 marks.
Yeah, really good.
It's really good for 3 marks.
But
Yeah.
you could.
Last question now.
I'll say that.
The next part we are going to do in the next lesson, but because this one is so easy, I think we can do it now. If I switch back to the question here, they ask us to integrate this. Now, this is easy because you have broken this into these 2 smaller problems. So integrating this just means integrating these 2, which we'll have a look at now. I'll write it here. It was to integrate from 2 to 3, which means you want to integrate this from 2 to 3 and integrate this from 2 to 3. Yeah. Both these are in the formula book. The integration of this is 2 log x minus 1. And the integration of this is log x plus 2. They're both in the formula book. We have to put in our limits, 2, 3 and 2, 3. So if I put in 3, what do I get? I get 2 log 2. And if I put in 2, I get minus 2 log 1, which is 0. And here if I put in 3, I get log 5. And then if I put in 2, I get log 4. But no, look, bring the 2 up there. So that's log 4 plus log 5 minus log 4.
Log 5.
Yeah, the answer is just log 5. And you can see, if I just switch back for a moment to the question, it says, give your answer in the form of log k, where k is an integer. So our answer is log 5. Now look how many marks that is.
5.
And look how many marks that was. So that's 8 marks.
Easy.
Well, this one I think was okay.
Seems a bit generous.
It's very generous, because look, you got 3 marks for finding those, and then you got 5 marks for getting there. So in total, this screen is 8 marks.
Okay.
Let's see what other integration comes up here. I don't see any. So we've done all the integration on that exam. So let's have a look at version 2.
Is it common, and yes, this is my final question,
Go on.
is it common for questions to be like this, or would it be harder or easier?
This was a bit unusually generous, I would say. Okay. Yeah, here's one for you to try. I'll just write it down on the. Can you all see that? Yeah. This was from version 2, the next version. So it's still 16, 17. No, sorry. 17, 18. Version 2. Question 7, A7. They ask you to integrate this for 3 marks. I'll give you a minute to try it before we look at it. Okay, give that one a go.
That's improper.
No, it's not improper. Yeah.
Do they have any limits?
No limits. So no subbing in at the end.
How many marks was this?
This was I've closed it. Does anyone have it open on their phone? I think it's 3 marks. It was 3 marks.
Seems
Got it finished?
Yeah.
Oh no, I've got it back here. Okay, shall we have a look at the answer here? So did some of you figure out what the first step was? Separate it, yeah. So you just have to split this into 4x squared over x, which is 4x, 5x over x, 5, and then 7 over x. Right, so this integrates to 2x squared minus 5x plus 7 log x plus c.
Okay, see.
Forgot the c, you lose a mark. 1 mark is lost for forgetting the c. Right, let's see.
Can it work with substitution?
Say again?
Can it work with substitution?
Oh no, this is the way to do it. What would you substitute?
X.
So all you've done is replace the letter x with the letter u. How is that better? Yeah, okay. Let me give you another one. Same paper, A10. Integrate 0 to 1, 9x, e 3x dx. And it does say by parts here. Gives you a hint, by parts. Oh, Amjad, I saw how to do that. It's what the video you saw, that integration. It's a sneaky little trick to it.
I remember that trick from English.
Very sneaky. I'll show you after this one.
Does that substitute?
No, it's he saw it as well. It's a +1 -1 trick.
The answer would be x minus 10.
Yeah, yeah.
It's a really
Yeah.
good tool.
It is really good. So much so, I think I might add it to the workbook.
Yeah, you should.
I think I will.
Give them just this.
I will, yeah. I'll put it in the back. Although I don't think he made this up himself. I think he saw it somewhere, so... right?
He mentioned it though.
Right, have we got answers here? So, what's f? 9x, f derivative? 9. G derivative is that, and then that is that.
Yeah.
Okay? Equals
9x.
9x by 1/3 e, so that would in total be 3x e 3x minus integrate f derivative, which is 9 e 3x dx, like that. Yes? So that's equal to 3x e 3.
Yeah.
Yeah.
It's,
Yeah?
yeah, it's E.
I lost my third here,
Yeah,
didn't I?
There's a third there.
Yeah, so that makes
3.
3 again, isn't it?
Yeah.
Yeah.
Fg minus. No! No.
Yeah.
Yes.
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 Yes, it is.
It's a 3. Fg minus f derivative g.
Yeah.
Yeah, so it's a 3. And then when I integrate, I divide by 3.
Yeah,
So
that's
in total, it ends up being just
just 1.
e3x. Yeah, one of them.
Plus,
Why is it not?
No, sorry, used up
plus C.
Zero.
Oh, no.
0, 1. No, oh, no, plus
Is
c.
it?
Is that used up? Did anyone see a mistake here that I made?
It's easier.
That's wrong?
It's like plus.
Oh yeah, I lost my x. The x fell off.
Yeah.
Yeah, well, that's, no, these things happen to x's. Right. Okay. Sub in 1 and sub in 0. So if I sub in 1, I get 3e3
Minus the three.
minus e3. Oh, so that's just 2e3. And if I sub in 0, no, minus 1. E0.
E0 is 1.
Oh, you thought you took a shortcut and you screwed up. 2e3 plus 1 is the answer. And I think the question said find the exact answer. Yeah,
So yes.
this is the answer.
Oh, wait.
Yes, Amjad?
When you substitute by 0.
Yeah.
1 minus 1.
What's 0 times anything?
0.
I think a minus
Isn't it minus 1 here?
Yes.
Minus
one.
e0.
Next, next.
Minus here.
No.
Yes.
This is right.
Confused about the minus one.
Isn't it just minus
It's
one?
plus.
Should it be plus one?
Yeah, yeah.
Plus 1.
It's,
No.
no, it's 0.
No, it's minus
Yeah.
1.
No, it's 0.
Zero minus zero.
0
Yeah.
minus 1.
It's 1 and 1 minus 1.
No, hang on, hang on, hang on. Now watch. If I put in 1, I get 3e3. We're happy with that?
Yes.
Yeah.
And if I put in 1 here, I get e3. We're happy with that?
It's fine.
If I, okay, good. If I put 0 in here, I get 0, which is there. I didn't write it because there's
Zero
nothing.
minus one.
And if I put 0 in here,
It's
minus e0 is minus 1. So are we happy with that?
Yes.
And minus makes plus.
Yes.
And 3 minus 1 makes 2.
Yes.
So what's the problem? Nothing's the problem. Yeah. Okay. 5 marks for that one. 5 marks for that one.
Fair.
Very fair. Right? 5 marks? Can I scroll down? I'll give you another one here. This is A11. X squared minus 3x plus 17 over x plus 2 times x minus 1 squared. And they say that's equal to A over x plus 2 plus B over x minus 1 plus c over x minus 1 squared, and they ask you for the A, B, and C for 4 marks. Give that one a try. Get the A, B, and C.
Second method.
Second method would definitely work here, for sure. We did something, basically we did something like this earlier today, yeah.
Yeah, in the tutorial.
The numbers look so similar. I think the only difference is I think we had x plus 1 and x minus 2.
Yeah, it's
That's
the,
all.
The X minus one.
Essentially the same thing.
Question 2 from the page is the same thing. The last question in the big answer.
It might have been, yeah.
So why is it C here and not CX?
They've given it to us.
We have to do it like that.
They tell us it's this, yeah.
See, if they didn't give us that A, that we can choose x minus 1, how can we know?
No. Remember the example I did earlier? I was showing you quite clearly that there are 3 different forms and they're all fine. They all work.
No, you
So
got
they have specified the form here. Think you got it?
The answers in fractions.
Yeah, like I was saying earlier, fractions are possibly fine here. Do you have a spare Casio I could borrow? Yeah. Thank you.
C is always
What did you get for A?
19 over 9.
19 over 9?
Yeah. Might be
What
something.
did you... Oh, goodness. Why can't we all get the same answer? 19 over 9. What did you get?
I got 1.
3.
1.
You got 3 and you got 1. And you're sitting beside each other. You got 1. You're the only one who got 19 over 3. Congratulations.
19 over 9.
Oh, 19 over 9, excuse me.
I might have just typed it wrong.
Possibly. Guys, I see some people are getting 1 and some people are getting 3. Did anyone get any other answer?
For A.
But yeah, for A. 3. Yeah.
odd numbers.
Which method did you use? Second method, yeah. And you got 3. You got 1. Ah, for goodness sake. All right, let's have a look. Okay, let's have a look. It'd be interesting to see what mistake people are making that are causing 2 different answers here. So let's have a look. First thing we do is we multiply across by x plus 2, x minus 1 squared. So we get x squared minus 3x plus 17 equal, no guys, come on. A times x minus 1 squared plus b times x minus 1 x plus 2 plus c times x plus 2, just x plus 2. Yes? So first thing, check that you got this. Right. I just want to get the A first. That's possible. It is.
When x
I choose x equals minus 2.
you should get 9.
Well, on the left, I'll get 4 plus 6, won't I?
10 plus 27.
10, 27. and then here I'll get 9a.
9.
So a is 3.
No,
How were people getting 1 though? How did you get 1?
This is switch between A and C.
You were giving me C.
Yeah.
Ah, the clue was I asked for A. So,
No, because no one multiple.
whatever indeed. Okay, how did you get 1?
I
Okay,
typed it wrong 3 times. Sorry.
okay. You typed it wrong 3 times.
Yes.
Nice. Okay, let's get, we could get the, what one would be easy to get next?
C.
C,
Minus
which I believe is 1. Okay, good. Good. And then, so we got C is 1, and did anyone get B yet?
Because C is 4.
So can you because
Fine. Right, what would give us, choose X equals
1.
1. 1.
that's
Yeah.
why I went wrong.
3 C is
1 minus 3 is minus 2, plus 17 is
10.
15.
Because 3 C.
3C, so C is 5. Yeah.
5. Yeah, nice.
But you're the one who asked me to do it.
Because I put 5, you do 1.
Well, he said 1, so he was wrong. Yeah. I believed you. And that was my mistake. You're right. Okay. Yeah. All right, so lastly, how can I get the B?
Substitute A and C into the equation.
What would be a good value for X? 0. So if I put in 0, I'll get 17 equals, shh, come on, stop it. 17 equals A,
3A.
which is 3. And this would be minus B. Minus B. And then this would be 2C?
Minus 2.
Minus 2b.
Is it minus 2B?
Yeah, minus 2.
Minus 2B. Yeah. Because the 2 here, thank you. Minus 2B. Plus 10. So I get 7 equals 3 minus 2B.
Yeah, B is 2.
Uh,
Minus 2.
is it 2 or minus 2?
No, minus 2.
Minus 2. Minus 2.
We can't.
You can say only the x squared. You already know A is 3 and
Could you do another question?
Hang
minus
on.
2 is squared. And B must be minus 2.
Wait. Amjad, get off the phone, please. Guys, be quiet, please, or I'll eject you.
I don't know how many marks for this.
I have to look at you two again. I'm ejecting you. Yes?
How many marks?
How many marks? 4. Now, what I want to do is, I want to see if the cover-up method will work here. You could possibly get it to work, but you have to be very careful. So I want to have a look here at the that method. So let me just delete this here. Now the cover-up method works really well when the numerators are constants and the denominators are linear. Now that we almost have that, except for what? The last one. Okay. Let's try the cover-up method here. So if we want to get the first constant here, we would have to delete which one? X plus 2. And what value do we sub in for x? Minus 2. Now I checked it out here. When you sub it in, you do get 3 here. So that's good. So I'll just write 3 here. Now here is the problem. You can't get the b, because what would you have to cover up here? X minus 1. But technically speaking, just one of them, because it's not a square. Now if you cover up x minus 1, what value do you use for x? 1. But you can't do that. But we could get this one maybe. What would we need to cover up? X minus 1 squared. And what value would we use for x? 1. So let's just sub that in and see what we get. 1 minus 3 plus 17 over 3. What did we get for c? 5. And this is 5.
So now you can just sub in.
Yes?
Now you can just sub in A and C and find it out.
Can anyone see? Now that we got A and C, there's actually another way to get the B without having to use the cover-up method.
Second method.
So let's just call this B here. And I'll give you a little hint. Remember, this isn't an equal, but rather identity.
So it's 3 plus
Or combine them.
Any ideas?
Combine them.
Multiply by denominator.
No, okay. So because it's an identity, it must be the case that for whatever value of x you use on the left, you get the same answer if you use that value on the right. So we need to figure out what b value to use so that we can get the same answer on the left and the right for any value of x. So if we were just to choose x as 0, what would we get on the left? 17 over 2 times minus 1 times minus 1. Yeah, so that's 17 over 2. That should equal 3 over 2 plus b over minus 1 plus 5 over 1. So let's see. 17 over 2 minus 3 over 2 minus 5. That will give me minus b. So then b I'm getting is minus 2.
So it's 2.
No, b is minus 2. I solved it fully. Yeah, I flipped the signs. So you could use the cover-up method, however, it doesn't work as nicely because it doesn't give you the b. But if you really want to use the third method, you can, but you'll have to do something about getting the b. Now, I don't know which you think is easier, what I just did or what we just did here.
I feel like the cover-up is risky.
It is. That's why I say only use it if there's constants and linear. Right. Just before you go, just so we can have a look here. Wait, guys, just before you go. Just to show you here, there's one more integration question in section B. We won't do it, but I just want to show you it. B3, B1. It was integrate x squared. No, stop. I'll just wait until people are paying attention. It'll only delay you going home. The question, integration question, x squared over x cubed plus 4 power 4 dx. And they tell you to use a substitution here, but you could probably guess what the substitution is. X cubed plus 4. And in this case, when you do substitute, what will happen is this guy will cancel with something here, leaving you at 1 over u power 4, which is u power minus 4.
Cancel 3x squared.
Yeah, the 3x squared is what cancels. Yeah. This was 4 marks. Okay?
You'd have to take 1 over 3 outside 4.
Yeah.
Yeah. It's not a big deal. Okay, so the integration in the exam is not too bad recently. And it's my hope that they'll keep it like that recently. Oh yeah, and sorry, the last one as well, there's a volume 1 where they ask you for the volume of this. So what happens? You square it, removes the square root, so it's like that.
5.
And the limits are 1 and 2. So you integrate a quadratic and you get a cubic. You sub in 2, you sub in 1, you minus. That was also 4 marks. It's okay, right? So I think the integration is fine if they're like this in the exam. In the older papers, whoever wrote them, they made it harder. But recently, the last 2 years, they've been straightforward. So that's good news for you, okay? We'll continue. So just so you know, I need double classes for the partial fractions. So whenever we have a single hour, it'll just be a tutorial. Okay? We don't have tomorrow, right? No. Here you go. Here.
We don't have EAC tomorrow, right?
Yeah, we just have 2 computers.